Hi, welcome back. Here we continue our study of trigonometry, and we're going to continue it by looking at angle-angle similarity. Well, how can we use trigonometric ratios? Why do they work? Okay, well, we have to look at angle-angle similarity. So remember when we were learning about similar triangles back in the previous unit, we learned that if you know that two angles of a triangle are congruent, then you know that the third angle is congruent, and that went actually all the way back to a unit before when we studied about relationships within triangles. So the reason a trigonometric ratio works is because, let's say I start up a new page and I have two right triangles, okay? Well, if I know both of them are right triangles, I know at least one angle. So here's the second right triangle, okay? So they're right triangles, so we know that those two right angles are congruent because we learned in our study of geometry that all right angles are congruent. Well, what if I call this triangle ABC, and then I call this triangle XYZ? And so what if you knew that angle B and angle Y are congruent? Well, if you know that angle B and angle Y are congruent, then you know that this third angle, so angle X, A and angle X, are also congruent. Why can we say that? Well, the third angle theorem. So if we know that all angles are congruent in two triangles, or all angles are congruent in two triangles, then we know that the two triangles are similar. Okay, so the triangles are similar. Okay, similar, not congruent. Well, how come we don't know that the triangles are congruent? Well, because we don't know the measure of the sides. We just know the measure of the angles. And we learned in similar triangles that if we know that all three angles are congruent, then the triangles are similar. So what does that mean about the sides? That means the sides are proportional. So that means that AB is proportional to XY, and it also has the same proportion of BC is proportional to YZ, and AC is proportional to XZ. Well, because all of these are similar, then we know that if we have two triangles with a common angle measure or acute angle measure, then because angle B and angle Y are congruent, we can say that angle A and angle X are congruent, which means that similar triangles have proportional sides. Okay, so that's how we can form these ratios and know that any triangle with at least one acute, any right triangle with at least one acute angle that is congruent to another one, then these same ratios will work for. Okay, so we'll talk more about that and get more in depth into right triangles. But for now, let's go back to our trigonometry unit. Okay, so in the last video, we learned basically what the study of trigonometry is and what a trigonometric ratio is. Well, now we're going to learn how to find them. Okay, there's three types, and we call them sine, not sin. A lot of students like to say sin, but it's not. The other one is cosine, and then the third one is tangent. Okay, so how do we find these ratios? Well, the sine, basically you have to pretend as if you're standing on angle A. So sine A means the sine of angle A, and sometimes you may see it notated as sine of angle A. You may see it written that way, and that way is correct as well. But we know that we're calling angle A with a capital A. Okay, so it's not a need for it right now. Okay, so if I'm standing on angle A, I want to look at the opposite leg. So if I'm standing on angle A, the leg directly across from angle A would be leg BC or side BC. Well, I know that if I'm trying to find the sine of just A, then it's going to be the opposite leg, which in this case is BC, over the hypotenuse. And the hypotenuse of any right triangle is always the angle across from the right angle. So that would be side AB or BA, whatever you want to call it. Okay. So if I wanted to do the same thing for angle B, I wanted to find the sine of B, then I'm going to stand here on angle B and I'm going to go look directly opposite. And where I look opposite of angle B, that is going to be side AC. So then we're going to have side AC, the opposite side across from angle B, over the hypotenuse, which is also AB. Okay, so that's not too difficult to figure out. Just remember that I want to look at the side that's opposite of the angle that I'm looking at. So if I'm on angle A, it's leg BC. If I'm on angle B, it's leg AC. Okay, so now how do we find the cosine? Well, the cosine is a little different. The cosine, let's go back to angle A. So I'm standing on angle A, and I want to find the cosine Well, then instead of using the opposite leg for the cosine, I'm going to use the leg that's connected to angle A. So we call it the adjacent side. So basically side AC is adjacent to angle A. So then for angle A, the adjacent side would be AC. And then again, we compare it to the hypotenuse, which is AB. Okay, so now let's look at the cosine of angle B. Can you guess which leg will be the adjacent side to angle B? So hopefully you guess that this side BC is adjacent to angle B. And so the way we're going to write our ratio is we're going to say, okay, BC, and we're going to compare it to the hypotenuse again, which in this case is still AB because we're talking about the same triangle. Okay, so what we've learned is that the sine compares the opposite side to the hypotenuse, and the cosine compares the adjacent side to the hypotenuse. Okay, so the way that we learn that is we can remember it by saying, okay, sine opposite over hypotenuse, and cosine is adjacent over hypotenuse. So we use the abbreviation ADJ over HYP, or for sine, we use OPP for opposite and HYP for hypotenuse. Okay, so I hope this video has helped. You can go ahead and stop, take a pause, and then tune into the next video so that we can understand how to find the tangent.